a fund of many, many kinds of varieties in almost all crops. Mexico is the proud owner of the genetic diversity of maize, corn, and therefore in corn growing areas, if you need to look for a property, you will head to Mexico and their gene banks and say, look, I have this area in Himachal Pradesh. They grow corn there. We are facing this disease suddenly. What can I use in my breeding experiments to solve the problem? Chances are you will find it. They'll say, okay, fine, we've got this highland maize, you'll probably find this. Another bunch of people goes from Rajasthan and says, we grow maize and we are facing this problem of salinity in our soils, and our maize is now not growing so well. You'll probably head to Mexico or to CIMMYT, where the International Bank is, and say, this is the problem I'm facing. And they'll probably tell you, okay, in the lowlands of Mexico or Ecuador or some LATAM state like that, this is this maize that grows there. Now, in one crop, you have a high temperature in Rajasthan, you have a low temperature in Himachal. They are both maize. They're facing different kinds of problems, and the chances are very, very high that you will find a solution to both. This is the marvel of genetic diversity. And to give you a real life experience or a real life example, in the United States, in the state of California and the West Coast, there is a huge industry based on melons. Not so much the watermelon, but the muskmelon. The muskmelon, do you know what the muskmelon is? Not the red one, the yellow one, the white one, the cream one, the peach one, the soft-fleshed one. Kharboos, we say in the north. I don't know what we say in the south. Huh? You say kharbuza? Kharbuza? Okay. So kharbuza is called the muskmelon or the cantaloupe. And the United States has a huge investment. Suddenly, they were faced with a fungal disease. It's a watery fruit, so it's prone to fungal diseases, and the muskmelon crop of the United States was threatened by a fungal disease that they could not control with anything. Where did they go? They came here. They came to the northern plains of India, which is where kharbuza actually originated, where its genetic diversity is available. And they went through all the old varieties and the wild varieties and took back material that was fungus resistant, bred it into their varieties, developed the fungus resistant strain, and resurrected their muskmelon industry. That is the value of the gene. That is the economic value of genetic resources. So this is a high funda thing, genes and genetics. And there is the down-to-earth wealth of information and material. So I would say that for India and for all countries of the world that have a large social sector dependent on agricultural activities, on activities that are rural in nature, this is a wealth that you cannot ignore. And the wealth is both the resource, which means that muskmelon variety or that rice variety. It's also the knowledge that is associated with it. Somebody has got to know what the property is. Just collecting those seeds and putting them away is not going to help you. That knowledge is equally important. So when Gene Campaign, which has in its seed banks 2,000 accessions of traditional rice, which we have collected from the Eastern Indian region, because rice is at home in the Eastern Indian region. It's not a Western Indian crop. It's an Eastern Indian crop. So starting from the northeast to down to Bengal, Bihar, Jharkhand, Odisha, this is where the diversity of rice has developed and remains and flourishes. So when we go to collect this material, then we ask not only for the seed samples, but we ask for information. And we ask the farm family for information, not just the farmer. The farmer gives us information, it takes that long to mature, it is resistant to these diseases or not resistant to these diseases. It will not tolerate acidity in the soil, it will tolerate acidity in the farmer who's actually tilling the land is likely to give you all this kind of information. But there's a much more important set of informations, or an equally important set of informations, that the farmer does not maintain, but the farm family, the farm women maintain. How long can you store this grain? Not all grain can be stored for equally long. How quickly does it cook? And why do you want to know how quickly it cooks? Because fodder, fuel are very important constraints in rural India. So if the rice cooks quickly, you have used 2 sticks of wood. If the rice takes a long time to cook, you'll have to use 4 sticks of wood. And you have to collect that wood. So you're very careful and conscious. So qualities like the keeping quality, the storage quality, and cooking quality. And very, very importantly, let me tell you another quality that the farm family will tell you, that the farmer will tell you, how quickly that rice digests. Do you get hungry very quickly after eating it? Does it stay for very, very long? Does it digest slowly? This is a hugely important quality. The rural community will tell you. When we go to till the fields, when we go to work, we eat this variety. Because when you eat it in the morning, you're not hungry till 4 o'clock in the afternoon. It's a slow digesting variety. There are other kinds of variety that are much faster digesting. These are all, I'm trying to give you a flavor of the kinds of properties that have been selected for, maintained, and kept, conserved by the farming community. It is very likely that the rice that digests slowly and the rice that digests fast have completely different starch profiles. If they have different starch profiles, they're likely to have some relevance for diabetics. Faster insulin peak, slower insulin peak, greater adaptability to people who are able to tolerate starch to sugar better than others. So your genetic diversity is not just about growing crops. It's about many thousands of things beyond that. And it is all of these thousands of things that are important to understand. Unfortunately, in our country, when we talk about food, agriculture, nutrition, we never talk about, with thousands of children under 5 dying of malnutrition, we still don't talk about it. We perpetually talk about agricultural production and increasing productivity. But what productivity do you want to increase? And how much of this are you going to be making relevant to the kinds of people that there are in your society who need different kinds of foods? And let me give you another insight into this, something at which the economist's eyes begin to sparkle. What is the economic value of these genes? Because after all these properties, whether it is salt tolerant or whether it is disease resistant, they depend on genes. The muskmelon guys wanted those fungus resistant genes. So your genes have today a value that can be traded economically. A disease resistant gene is worth many, possibly thousands, possibly millions. If you can save the entire muskmelon crop and muskmelon industry of the United States, how much have you saved by that one gene? And I would urge you, and any of you who have aspirations to become the leading economic advisors to whoever you want to advise, to not think of genetic resources as soft resources. Oh yeah, some fuddy-duddy farmers want to grow this, and if they want to do it on saline soil. Here is hard economics. We need to get our heads together and evaluate these resources, not just for the social sector. Of course, they're important for the social sector indirectly, but also directly. How do you make this resource a valuable resource which is good for all of us? Because if a particular community in some particular area has been conserving a particular crop variety because it is suited to that niche, that community is sitting on gold. We have just finished doing an exercise using GIS mapping and climate analogs to map the genetic diversity of rice that is available in the Gene Campaign collection, and plotted it across Asia to see where in tomorrow's climate these varieties could be adapted. So the IPCC projections of 2020, 30, 50, 80, you have now with climate modeling projections about whether that's likely to be in 2020, in 2030, in 2050, in 2080. We can tell you today, depending on our collection and the GIS coordinates, that this variety in 2030 is likely to be suited to this location. Because I know what that weather will be in 2030. I know my GIS coordinates for this particular variety, and I can project and tell you that when your varieties there die because they have become not suited to the new climate that you're going to face in 2020 or 2030, I can tell you which varieties are likely to grow there. This is the power of genetic resources. So here is a little snapshot of how important it is and how neglected it is in public policy. And what are the challenges to it? Even before we begun to understand, acknowledge, and internalize the hugely important nature of this resource, we are already facing the threat of losing it. And guess what's stupid as hell? Stupid as hell is losing your strengths and doing nothing to stop that erosion. Every time you lose a variety, you've lost those genes. Every time you've lost those genes, you've lost one more possibility of coping with future challenges. But there are several kinds of challenges now to genetic resources, to genetic diversity. The loss of varieties and cutting down of forests, etc., you all understand. But the whole international trade regime, the WTO, the TRIPS, that wanted intellectual property rights over genetic resources, was an institutional challenge that came up in the 90s and that we in India to a large extent were successful in fighting. And that was the patenting of seeds. The patenting of seeds means the patenting of varieties. Oh, here's an interesting one. This one is actually quite drought tolerant. Why not just go ahead and patent this? Why not just go ahead and make a cross out of this and patent that? So control over genetic resources. And there's a reason why suddenly this has happened. The reason for that is the development of biotechnology as a sector, which has become far more visible, dominant, aggressive than genetic diversity. But the raw material of biotechnology is genetic diversity. You can fiddle around as much as you like in the lab unless you have the proper genes. You can't do anything with biotechnology. And the rest of our lives are not going to be based on BT genes and HT genes. If you want to grow this technology, if you want to do anything meaningful, worthwhile, and relevant with this, you'll have to keep looking for genes. But there is a dilemma that happened in the development of biotechnology. And that dilemma is that the lab guys were usually in the United States, the ones who knew how to cut and paste the genes. And the genes were here. Here means maybe India, maybe Malaysia, maybe Philippines, maybe Sri Lanka, maybe wherever. So the genes are here and the labs are there. So how do you get hold of those genes and stick them in the labs and get rights over them? And the answer to that is intellectual property rights. And how do you enforce intellectual property rights across the globe? it's not enough to do it in your own country. You have to do it across the world so that you can access the genetic resources of the world. And the way to do that was through the TRIPS of the WTO. I'm sure all of you have at some stage done that in your courses or your studies or whatever. But the trade-related intellectual property rights regime of the WTO, of the Uruguay round, was one of the most serious intellectual challenges to have confronted the integrity of genetic resources as a fundamental resource available to rural communities in the countries of origin where those resources were found. In the first lot, I would say that India, after significant battles, and Gene Campaign has been very much in the forefront of these battles. In fact, it is to Gene Campaign that I would say the credit goes for spearheading this national campaign against seed patents, and ultimately working with government, working with successive governments and joint parliamentary committees, 3 governments, to finally get the legislation that we call the Protection of Plant Varieties and Farmers' Rights Act. The Farmers' Rights Act gives farmers the rights over seed. And therefore, we've managed for now to stave off the patenting of seeds. So India is the only country in the world, that has struck an individual independent path in trying to protect the rights of farmers over the rights over the genetic resources. But let me assure you, this challenge is not over. It has come up again. Now, as we talk, there are renewed negotiations over intellectual property rights in the biology sector, and I think you need to be worried about that. So I wanted to give you a flavor of why this resource is important and why it is crucially important to the social sector, and why it is crucially important to the most significant social sector, and that is the rural community, who have its information, its knowledge. And therefore, I have maintained in every policy body that I managed to get a voice in, that this is an enormously wealthy and important resource for this country. It's also enormously wealthy and important because communities remain in control of it. We don't have to bring it from somewhere else and become benefactors. It is theirs. The knowledge is theirs and the resource is theirs. All we have to do is stop being unfair, stop being unintelligent, and recognize the potential of this resource to do that which we are all trying to do, and that is grow the social sector. In this case, you'll be able to grow it in a nice, holistic, self-reliant way. Thank you.
Thank you, ma'am, for your valuable insights and providing us a new perspective on social sector development.